All right, so in this section, we're going to be looking at rational exponents. This just means, that the exponent itself isn't a whole number. It's going to be some sort of a fraction or a decimal, and we're just going to, we're going to use this rule up here in order to simplify it. Okay. So the most common one that you're familiar with, I'm sure you know how to handle this right here. This is, just the square root, and it means, some number times itself twice will give us 16. And of course, that is a 4. Now, when it's written just like this, where there's no number here, it's actually an assumed 2. And that's called the index, right? The indice of the root. So it didn't have to be a 2. Let's say we had something like this, where it was the third root or the cubed root. This just means we're looking for some number multiplied by itself 3 times that will give us 8. And that would be 2, of course. When you're given, when you're given an expression that has a fractional exponent, you're going to take the denominator, and that's going to be the index of your root, right? So like a 3 or a 2. That would mean the 2 is the denominator, or the 3 was the denominator. The numerator of the fraction is going to be your power, all right? You could either write that power on the inside of the radical, or you can write, as the whatever your index is, and then all of that stuff to the power. Right? You can evaluate it either way. So as an example, we'll do 9 to the 1/2. So we'll have a root with a 9 here, and this is 9 to the first power, although that doesn't matter, and a 2 out front. So we're looking for some number times itself twice that gives us 9, and that's going to be 3, of course. Right? If we wanted to simplify this, we're really not going to be able to simplify it, but we are able to rewrite it. Instead of having a fraction for an exponent, we can write it as a radical somehow. Right? So the 3 is going to be our index. So we're going to be dealing with the third root, and then we'll have a 6 to the second power. Right? And then you can just evaluate this if you want to. That would be the same as the cube root of 36, and you can't really simplify this any further. There's no number that you can find that such that when you multiply it by itself 3 times that you'll get 36. This isn't a perfect cube, is what they would call it. On our next one, we've got 4 to the 3/2 power. So we'll have a 2 on the outside, so this is a square root, and we've got 4 to the third. All right. Now, if you want to, you can just leave off the 2 because it's, an implied or an understood 2 whenever there's no number out there. We've got 2 ways we could think of this. We could think of it as the square root of 4 to the third, which is 64. And then we could evaluate that and call it an 8. All right. Or we could write it like this. We could do the square root of 4. And then that 3, instead of putting it on the inside with a 4, we could have put it on the outside. All right. The square root of 4 would equal 2. And then we would take that to the third power, which of course would give us 8 either way. All right. One last here. We've got 27 to the 4/3. So we could write that as the third root of 27 to the 4th. But most of us don't know what 27 to the 4th is, much less what the third root of that is. So we're going to write it using the second method here. So that would be the cube root of 27. And then we're going to raise that answer to the 4th power. Right? The cube root of 27 is going to be 3, because 3 times 3 times 3 will give us 27. So this will be a 3 to the 4th. Let's see here. 3 times 3 times 3 times 3. Well, 3 times 3 is 9. 3 times 3 is 9. And 9 times 9 is 81. So this one and that one, they actually simplify completely. So that's really the only lesson we can talk about right now as far as fractional exponents. We're just going to be rewriting them so that they have in a radical form, and then we'll see if that radical form will simplify itself. Okay.